Okay, so this is the first video I wanted to make about looking at an actual practice assessment for the trig internal that you guys will have. And I wanted to look at this from the achieved point of view, from the I'm just here to survive point of view. And for some of you girls, you look at a problem like this, you see a big diagram and heaps of words, and the words kind of scare you a bit. So what I would do is encourage you guys to actually ignore the words. And think about one way to get through this assessment is to actually just be able to demonstrate that you've used maybe 3 or 4 different formula. And so from the formula sheet that you've got, just focus on the picture and think about looking for things that you could solve for. Whether they're actually solving for what the problem's asking for or not doesn't matter. Just think about demonstrating you know how to use these formula. So that's the cosine rule, the sine rule, your area formulas, using radians with your arc length and your area of a sector, and any of those. So when I first look at this problem, I'm going to start looking for things that I know how to solve. And I notice just within inside of this first triangle here, OBC, I've got an angle and 2 sides that are sandwiched next to each other. That means I've got a side over here that I don't know, and I'm noticing here that I can use the cosine rule. Because I have angle A, I can look for little a. I've got a side B and a side C as well. So I can use the formula to actually solve for that. So let's go ahead and do it. Where do I want to put this? Let's just add a page so that we can use that. So, other way. So one step at a time. Here we've got a picture we can use. So again, this would be angle A, side B, side C. And we're going to use the cosine rule for this one. So this is in triangle OCB. I'm just giving the letters at the corners of the triangle to help identify what I'm dealing with here. So to find length CB, which we're going to call A right now, we'd say A squared is equal to 25 squared plus 32 squared minus 2 times 25 times 32 times cos of 75. So A squared is going to be equal, in this case, to 1,234.89 centimeters. Oops, not centimeters, meters. Okay, so that's what A squared is equal to from our cosine rule. And again, this is the cos rule for sides on your formula sheet. And remember the last step on this, we actually have to find A squared by finding the square root of both of those. So A is going to be equal to the square root of 1,234, which is equal to 35.41 meters if we round it to 2 decimal points. Okay. So that's the length of CB, and here we've demonstrated the use of one formula. And just sticking inside of that triangle, I'm going to try to think of anything else that I might be able to find. And we might be able to find the area of that triangle. So let's find the area of triangle OCB. And this would be using the area formula, where we have 1/2 times B times C times sin of A. So labeling again, we can actually keep the labels the same. We can call that angle A, and we've got side B and side C. So the area is going to be equal to 1/2 times 32 times 25 times sin of 75 degrees. And the area in this case is going to be equal to 386.37 meters squared. Watch your units. Remember that area is in meters squared. So that's the area of triangle OCB, like we just said. Cool. So now we've demonstrated 2 formula that we can use. And it's probably time to look at other spots on the diagram and see if we can figure out what else is there for us to solve. So, just to look for things. I don't know much about this triangle here. I only have one side, no angle, and I don't have the two other side information, so not much there. Here I've got an arc length of 59.1 meters squared. That's the arc length. My formula for that, again, is r theta. I know that the radius here is equal to 25 degrees for that, or sorry, 25 meters for that. Oops. Don't want that to do. 25 meters for that particular shape. So, I don't have the degrees here, I don't have the angle, but I do have the arc length and I have the radius. And let's look at the other triangle here. I've got one angle and one side, and again, not much information there. So we have to be thinking just a little bit harder about what other information has been given to us that we haven't noticed yet. And one of those bits of information is actually going to come from the fact that we can use the arc length formula to actually find out how big this angle is. You'll notice that we have 51.9 is equal to r theta. And in fact, we have 51.9 is equal to 25 meters times theta, or that angle that we don't know. So we're going to call this one here theta. That's the angle for that sector. And in this case, we only have one unknown, so we can actually do a bit of algebra here. And what we will do to actually solve this problem is divide both sides by 25. So it cancels there, and we've got 51.9 divided by 25. And in that case, it is equal to 2.076. And remind yourself that this is radians because we're looking for the theta, and that is in fact equal to the angle. So now I know the angle of that surface. So that's one other formula that I've demonstrated, and actually at a pretty high level. Now, any of you freaking out because I use the word algebra, let me just give you this to memorize if you would like to. Oops. Sorry, I keep erasing that picture. Your formula is given to you as the arc length is equal to r theta. So if you need to find theta, it's going to be equal to the arc length, abbreviate as AL, divided by the radius. And if you need to find the radius, it's going to be equal to the arc length divided by theta. So those are shortcut formula you can use if you need. Okay, so we have now found three things. We've got the length of one side, CB. We've got the area of one triangle here. We have now an angle for the sector. So we can potentially find a bit more information. We can find the area of the sector, and we know that formula. So let's go for that one. Area of sector, and this is OCD is the sector that we're looking at. And the area formula for the sector is 1/2 times the radius squared times theta. So we'll just plug that in, 1/2 times the radius, which was 25 meters squared, times theta. And remember, since it's theta, it's looking for the angle, but it wants it in radians, so we're going to use that number, the 2.076 radians. And putting all that information in, we get an area here of 648.75 meters squared. Again, watch that you're using the squared bit because it is area. So you're well on your way to achieved here. You've in fact done quite well if you've got this bit. So you've got, again, the use of 1, 2, 3, 4 different formula. So that's pretty awesome. And if we just look around a little bit further and just see how much more we can go here before we actually give up on it, is let's add some information that we've got. So I know that that angle is actually 2.076 radians. And remember, for radians, it's not helpful for us in any of the other formula besides arc length and area, which we've already used. So one idea might be to convert 2 degrees, and that gives us some more information about the other triangles. So remember to convert to degrees. If we've got theta and we want to get to radians, we're going to take the if we've got radians, 2.076 rads, and we want to get into degrees. We want degrees, so we're going to leave the degrees on top of that fraction. So 2.076 times 180 degrees divided by 2 pi radians. And I might actually just draw that out as a fraction, because that's how I usually do it. Divided by 2 pi radians. And when you do this, you get 118.95 degrees. So again, more information, and that's just giving us use for more formulas that we can look for. So we're going to put in the angle here, 118.95. Awesome. So from that, we could think about how many degrees around a point, and you remember that from year 11, we've got 360 degrees in an angle. So this one here could be 360 minus 75 minus 69 minus 118.95, and we will get from that 97.05 degrees. So now we know an angle, another angle in there. So we've got one side and one angle for that particular triangle. And there's still some bits that we don't know, like this side here. And we don't know that side either. But I'm gonna point out one that might be less obvious to some of you guys. Remember, a sector is just part of a circle. Now let's look at that sector. Part of the circle. And so in a circle there's always going to be a radius, and in this case the radius is 25 meters. Now every single radius within that circle is going to be 25 meters as well. So if you know that this radius over here was 25, that means this one also is 25. So just by looking at that diagram and paying attention to the fact that we have a sector, so both sides of it, if you will, should be equal to each other because they're the radius of a circle. So 25 meters, that means this side over here is 25 meters. And now you'll notice we've got an angle side pair, and potentially we can solve for another angle side pair using the sine rule. That would give us that angle. From there we can find this angle up here using 180 degrees within a triangle. Heaps of different things we can go to from here. But I'm going to go through all of that in more detail in the video for Merit and Excellence. I really just wanted to give some of you guys who are a bit scared by this hopefully some confidence to think about how you can go about solving the problem. So at this point you've basically passed this test and you haven't even read the word problems yet. So again, if that's something that's startling to you, just focus on solving as much as you possibly can. Make sure you use at least 4 different formula, and then at that point maybe it's time to go back and read the words once you've got some confidence under your belt and see if there's any more information you can actually solve for. So take a look at the next video if you'd like to take a look at how that goes, and I'll take it all the way through to excellence in that one.